We're on lesson 4 of chapter 11, which is inequalities. First, we're going to write inequalities. Then we're going to graph simple inequalities. Then we're going to graph compound inequalities. Well, what is an inequality? Well, an inequality states that two quantities or two numbers either are not equal or may not be equal. So that's how they kind of split this up. First, let's look at the ones that are not equal. When you see a symbol like this, when it's pointing away from the left side, that means it's less than. A couple other words that you'll recognize with this would be fewer than or below. So whenever you hear those words, that also means the less than symbol. When it's pointing towards the left side, that means it's greater than. And a couple other words you'll hear is more than or above. The other type would be may not be equal. So it could be equal, but it might not be. So when you see the symbol facing away from the left side and has a line underneath it, that means it's less than or it's equal to. A couple of words and phrases to know would be at most or no more than. That means this symbol too. When the symbol's facing towards you and you have a line underneath it, that means it's greater than or it's equal to. A couple of words to look for would be at least and no less than. We're going to be working with algebraic inequalities today, and that's an inequality that contains a variable. So for example, if we have a here and we have the greater than symbol next to it, that means a is greater than 5. To show that on a number line, we would put an open circle at 5 because an open circle shows that 5 cannot be a solution, because if a is greater than 5, it means it can't be 5. And we draw the arrow towards the greater numbers. If you have b is less than or equal to 3, we would do a closed circle at 3 because that means it could be a solution at 3 because it could be equal. Then we're going to have our numbers go down to the negatives. So first let's write some inequalities. So it says write an inequality for each situation. There are at least 25 students in the auditorium. And the words that jump out to me would be at least 25. So at least means greater than or equal to. So if we're going to write an algebraic inequality, if we'll do S for students, that would be greater than or equal to 25. So that means it could be 25, but it also could be 26 or more. Now we have these words. No more than 150 people can occupy the room. No more than was less than or equal to, meaning that we'll have P for people, and it's no more than 150. It's less than or equal to 150, meaning you could have 150, but that would be the most you could have. 149 on down could be the solutions to this one. So now we're being asked to graph each inequality. So we have x is greater than negative 2. So first we have to figure out our scale whenever we do these, and if it's close to 0, we can usually have a 0 in the middle and just count by 1s on each side. When it's not, we can count by 2s, or we can actually not even start with 0 in the middle. We could do something else. But since it's pretty close, we can work with this. So since x is greater than negative 2, remember we saw that when negative 2 is not a solution, we have to have an open circle. So we would have an open circle at negative 2 because x can't be negative 2. And since it's greater than it, meaning that it's a higher value, we would go in this direction to the right because these numbers are greater than negative 2. Now we have negative 1 is greater than or equal to y. So if you look at it from y's standpoint, it's less than or equal to negative 1. So we can start with 0 here, 1, 2, and 3, negative 1, negative 2, negative 3. Since y is less than or equal to negative 1, I can put a closed circle here because negative 1 could be the solution, and then it's going to be less than that. So we have to go to the left direction to show that y is less than negative 1. Now we can do some compound inequalities. So this means that it's going to be either an or situation or an and situation where it has to fit both numbers. So we have m is less than or equal to negative 2, or m is greater than 1. So if we start at 0 again for our first value, and we'll count to 3, we'll say, we can take these one at a time and solve this. So m is less than or equal to negative 2. So since it could be negative 2, we'll do a closed circle. Less than negative 2 would take the arrow in this direction. So if we do m is greater than 1, let's put our number line here. We'd have an open circle at 1, and we would make m greater than it by going to the right. So now we could put these two together in a compound. So we still have our same scale here. And we could write both of these on our answer. This one will be our answer. So we have closed circle at -2 going in this direction, open circle at 1 going in this direction. So these would show the values of m. It's either going to be over here, less than -2, or it's going to be over here, greater than 1. Now we can do a compound inequality that has to fit both solutions. Since these are both close to 0, we'll just start at 0 and count by ones. So let's graph these inequalities out. So when you have this kind of inequality with a straight line like this, -3 is less than b, which is less than or equal to 0, we can look at the viewpoint from b. So b, if we go to the left, b would be greater than -3. So if we go to -3, I would put an open circle at -3 because it can't be -3 because it's not equal to. And we would have our arrow going greater than -3. If b is less than or equal to 0, I would put a closed circle at 0, and I would go to the left because it's going to be less than or equal to it. So now when we do our compound inequality, we would have to put this together. B has to be greater than this, but it also has to be less than this, meaning that it can't be anything below here. So even though this arrow is going below it, we have to stop it right here. And even though this arrow is going past that 0, we have to stop it here because that's the biggest the 0 could get. So we'll plot our circles, the open circle at -3, the closed circle at 0, and in this case you just connect the lines, and this would be your answer. B is greater than -3, but still less than or equal to 0. So these would be the only solutions to this inequality.